Sweet. We're live. Welcome everyone to another episode of Workshops. We have Nazi with us. Super excited for this one. He's going to be talking about writing, testing, and deploying a Vyper contract using Foundry. But before we get into that, Nazi, can you tell us a bit about yourself?
Sure. First of all, thanks, Rupas, for having me today. So my name is Nazi, and I am a front-end engineer. Uh, I know full stack, but that's for my personal projects only. And I'm also like a member of Developer DAO and Gitcoin DAO. And apart from that, I love building open source projects, public goods, and share knowledge in articles and doing workshops just like this and publishing video tutorials. So that's a bit overview about me.
That sounds amazing, dude. So happy to have you here. And as a little bonus for our viewers, since Developer DAO just got 80K friends on Twitter, do you want to tell us briefly about your journey in the DAO?
Sure. So last year in October, I joined Developer DAO. So this month, it's my 1 year anniversary in Developer DAO. So yeah, it's like when I joined Developer DAO, there were just like 10 channels, and like me, Manny, and Vidhat, Daivat, and some more people were like just doing few
Sorry.
stuff, building projects and stuff like that. I was actually contributing to Developer DAO even before joining the DAO onto the website. So, like after basically contributing to the projects to the DAO, I got to join the DAO, and then I started uh, taking parts in town halls, weekly calls, weekly meetings, and contributed to a lot of projects in Developer DAO like Web3 UI and the whole website. I championed that like the current version, and also currently I am championing the lens subgraph in Developer DAO. So that's some of the things that I have done in Developer DAO.
That's amazing. Like anyone who knows Nazeef from Developer DAO, you'll have seen the great work he does. Like he's an amazing front end dev, but not just that. He's like always willing to help people out as well. Do give him a follow at Nazi21 on Twitter. And yeah, so let's just like get into the topic now. Can you give us a brief about what you're going to be talking about? What you're going to show us
Sure.
today?
Yeah, so today I'm going to be discussing like how we are going to we are going to firstly write a basic Viper contract, and after that we'll compile it using Foundry, and then write tests for that in Solidity using Foundry itself, and then we are going to deploy it. So that would be the pretty agenda for today.
Hmm. Sweet. So, can you tell us a little bit about what Viper is and what Foundry is?
Sure. So let's start with Viper. So Viper is basically a programming language which is basically based on Python. So it's like like you can write smart contract in Solidity, but not all the people know Solidity, and also like it is a bit complex. And not very beginner friendly. So what Viper aims to it brings to us a language to write a smart contract which is very human readable. Basically, like even looking at the first glance, person comes to know that okay, this contract is doing this stuff, and these are the functions, and basically understands the whole contract by just having the first glance. So Viper helps us to like write a contract which is very human readable, which is very easy. Like Python is very easy language, so it is already based on top of that. So yeah, in a way, Viper enables us to write a smart contract which is very easy to write and also human readable. And yeah, also like Viper follows the Python syntax. Like you can, if you know Python, then you know Viper, and you write a smart contract on top of that. So like you are pretty much good to go. And Viper follows all Python 3 syntax, but all the Viper is not Python 3. So that's kind of the thing that a little bit what we can say crossover that Viper follows. And regarding the Foundry, Foundry is Ethereum Development Environment, just like our hard hat. But what add-on functionality does it have over hard hat? So, in hard hat, we used to write tests and scripts using JavaScript, but Foundry enables us to write all those scripts as well as this test in Solidity. So it's very fast. Like it saves all the time of compiling JavaScript and then testing. Instead, it just tests or runs the whole Solidity code, and so it is very fast. And also, like Foundry comes with these library called dapsys test for asserting values. So like it is like for any asserting value, you just have to write assert equal and it will assert the values for you. And also like for logging values, like we often used to log values. We can very easily log anywhere, like by just typing a keyword like emit log. So like if you let's say if you want to log any value, then we just have to write emit log and then pass that value, and it will log that value in your console while running that particular command or script. And also, like one thing which I personally like about Foundry is like it provides us with a detailed analysis of our scripts regarding gas, like how much gas this script or let's say this command is going to consume, so we can optimize on based on of that. So that's pretty much a brief overview about Foundry and why I personally prefer Foundry on over hard hat.
Thank you for those great explanations. I'm super excited to see how Foundry and Vyper work. Have been wanting to learn Foundry personally for a while, so this is going to be really exciting. So before we dive into it, if anyone has any questions, y'all can put them in the comments.
Sure.
If not, yeah, let's just head into it then.
Cool. So let's just dive into the code editor and start writing smart contract in Vyper. So let me share my screen real quick. Is my screen visible now?
Yeah, can you zoom it a little so that people can read it?
Sure. Is it fine now?
Yeah, that looks great.
Cool. So just a second. I think it is now readable, right?
You might want to zoom your terminal a little bit more.
Is it fine now?
Yeah, that's great.
Okay. So first of all, to initialize Foundry project, we need to write Forge in it and then the name of our folder in which we want to initialize that. So we are going to start writing by Forge in it, and I'm going to name this folder as Foundry Workshop. So it will go ahead and create a boilerplate for us to start working on with all the libraries installed. And I'm gonna just go into that directory. And I'm gonna open this folder in my code editor. Oops. Yeah, perfect. So let me zoom it as well. So let me give a brief introduction about this structure. So our project folder consists of basically SRC folder, which contains that contract.sol file where we'll be writing our smart contract. Then this test folder where we will be writing our tests, and the script folder where all the scripts like deployment scripts, and even if we have more than that, we can write in this script folder. So let's start by writing the contract, Vyper contract. So for that, first of all, we are going to rename this file to count contract .vy, because like we are writing Vyper contract and its extension is .vy. So now I'm gonna delete this whole thing, and for this tutorial, I'm going to write some simple count contract which allows us to increment and decrement that value, and we can also set that value so that it is pretty understandable to everyone. So let me just go and write that. This is the basic Python syntax. Like I'm not going to uh, write any new programming language. So anyone who knows Python, they can understand this. And here I'm going to define its type, int 256. So this will be my count variable, and I'm going to increase and decrease its value. So now let's say external, and I'm going to define a function, basically a constructor function, which we have in Solidity. And for here in Vyper, this constructor function, we have to give it a name init function, which will get executed whenever we will be deploying our smart contract. So this Copilot predicts that perfectly. I'm just gonna hit a tab. So what it basically does, it accepts an argument called count variable, which is of the same type as count, and it will then assign this value of count to our count variable. And after that, we are going to have increment, decrement, and set count function. So again, external and definition, that set count. Now here we also need to accept an argument to set that variable, just like this, so that we can set the value of our count. So I'm just gonna hit tab again. So you can see I'm accepting a count variable, and I'm assigning that value to our count variable over here. And now we need to define increment and decrement functions. Increment, and this will just increase the value just like that. Perfect. And again, decrement. GitHub Copilot is really awesome. Yeah. And lastly, the function which will just return us a count value. So external, and perfect. So this is pretty much our Vyper contract. And now I'm going to basically compile it and then write test for it.
So I have a quick question, if you don't mind.
Sure.
I'm not entirely familiar with the Python syntax. So I see you're initiating the count variable, and then you're again assigning it to self.count in the set count function. So why are both of these steps necessary?
Let's say if I'm going to just assign the any value to my count variable here only, then what it will do, like whenever we deploy our contract, that value is in our variable only. We can't modify that on while running our command, or let's say deploying our contract. So what this will allow us, that we can dynamically set the value to our count variable while deploying. So let's say my mind has changed, and now like I want to assign a different value, which is not the same as the initial value. Then it provides us with that functionality, or let's say with that capability. So that's the reason I have set the value in the constructor and not assigned it over here only.
Okay.
Yeah. So now we have a contract ready. So now let's just go and write a test for it. But before writing test, first of all, brief introduction about how a test works in Foundry. Any file which has .t, .sol extension, Foundry considers that file as a test file. And whenever we will be running a command for test, then it will go ahead to our entire project folder, and we'll see that, okay, which are the files with .t and .sol extension. Then it will run that file. So all the file with .t and .sol extension are considered to be a test test files. So we'll be writing our test here, but before writing our test, we need to compile our contract, right? So that we can interact with it. So let's imagine that we don't have Vyper, this Foundry setup. Then how we are gonna uh, compile a Vyper contract? So for that, compiling our Vyper contract, the command is simply Vyper and then name of our file, which is count contract. So this basically returns us bytecode for our contract by compiling our contract. So we'll be using this bytecode to interact with our contract. But how we are gonna provide this as an input, or let's say uh, tell this test that use this bytecode and uh, execute tests for our uh, contract. So for that, we will be doing we will be writing one script which will run this command and will give output this bytecode and the address at which our contract is deployed. So let's write that script. So that script is basically, let me share the link with you guys. Okay. So here I'm going to be copying this whole script from here and create a new folder, utils, and in that let's give this name Vyper deployer. Yeah, this is going to be a Solidity script. So let me just give you brief whole thing works. Which will take the name of the file which we want to deploy and will return the address at which the contract is deployed. So what we are going to do, we will call this function, pass the name of our contract here as an argument, and we will be getting this address at which a Vyper contract has been deployed in return. So we will be using this script. So let's just go and use this script. But before that, this script is only returning our address at which our contract is deployed. While for running test, we require two things, which is like interface, which is the ABI, and the other is this address. So we are getting this address from here. So for ABI, we have to define something called interface, which we'll be using to interact with our contract. So let's just create a new folder in test directory and give it a name interface. And over here, I'm going to be create a new file, I count contract. This signifies that we are creating an instance. Perfect. So what this file is basically contain, like this will contain all the interface which we will be using to interact with our contract, Vyper contract, and the address from this script. So let me just go and define write this interface. So pragma and solidity, which is used to signify the Solidity compiler version, by which we want to compile this. And I'm going to be using a Solidity version 0.8. Yes, 0.8.13. Perfect. And now interface, then I'm going to name this interface as I count contract itself. And over here we will be defining, let's say, give a brief, or not brief, actually we will be defining all the functions which we have in our contract. So if you remember, we have this set count, increment, decrement, and get count. So we will be briefly defining all those functions over here. Function set count, and this is basically an external. This was actually an external, as we can see here, and external, and this don't returns anything, so we are not going to write anything after external. Perfect. And yeah, just like this, increment and decrement, as well as this get count. Perfect. At So our get count is returning u into 56 variable, which is count. So we have this returns, which signifies that we are returning something, some value which is of the type u into 56. So this is the interface for our smart contract. So now we will be using this interface as well as the address returned from here in our test contract. So this is the testing library which helps us to assert values in our test. So I have imported that, and now we need to import two things basically. First one is that Vyper deployer, which we'll be using to deploy our Vyper contract, and second one is this interface. So let's just go import utils and Vyper deployer.sol, and yeah, perfect. So these are the two things which we need. So Vyper deployer.sol, perfect. So this is the boilerplate which basically comes predefined when we initialized our project, and this has two functions, namely setup and this is the test example. So setup function is a function which will get executed before running our each function over here. So let's say we don't have only one function over here, we have multiple, let's say. Then this setup function will run each time before executing each of these functions. So let's just add something inside each of these functions. So first of all, I'm going to create an instance for a Vyper deployer contract so that we can use that and deploy our Vyper contract. So yeah, this Copilot is predicting perfectly. We will be defining a variable deployer which is of the type Vyper deployer, and after that I'm also going to initialize this in this only line. Perfect. And after that I have to define a new variable of type count contract, and I'm going to name this contract as count contract only, but I'm not going to initialize it because this is something which I'll be doing in this setup function, so that every time I run a new function, our new contract has been deployed. So let's just use this deployer variable and deploy our Vyper contract in this setup function. So what I'm gonna do, I'm gonna call this count contract equals to perfect. This is so. Let me give you a walkthrough of what is happening over here. So wait, yeah. So we are initializing this count contract variable, and for initializing instance, we have to call iCount contract, and in that we have to pass the address for a Vyper contract at which it is deployed. So what I'm doing here, I am calling this deployer dot deploy contract. So this deploy contract is basically this function which we have defined in our Vyper deployer contract, and it basically returns our address. So I have called deploy contract, pass the name of our file, and this is basically an argument. So remember, we have two deploy contract methods. The first one only accepts file name, and the other one, along with the file name, it also accepts arguments. Just like we have this constructor argument count variable in our constructor for our contract. So we have passed that variable over in the second argument, and we need to wrap that argument in abi.encode function, so that which is basically accepted expected what we can say expected
The
format
type.
for our
Yeah.
yeah, expected format in our function over here. So we have to encode each and every argument to our contract constructor in abi.encode, and this will basically create a brand new instance for our count contract. So from now, from this point onwards, it is basically our solid. It will behave just like a solidity contract. It will no more behave like a Vyper contract, and it is something different from solidity. So now we can just write all our functions just like we have our solidity contract. So let's just delete this function and write a new function to test set count method. Set count. This is going to be public, and yeah, that's perfect. So this is so in this function we will be setting we will be testing our set count, and we will be calling this set count method, and we will be asserting after that that our contract is behaving as expected or not. Again, after that we will be testing increment as well as decrement function. So function test increment, nothing in an argument here, and again this is going to be a public function, and count contract. Yeah, perfect. So as you can see that we are initializing our contract with the initial value of 10. So on incrementing that variable, we have to assert it to a value of 11. So we have passed 11 over here, and again likewise decrement test decrement. Perfect. So yeah, so now I guess we have pretty much written tests for all our functionalities. So let's just go and test our or let's say run our tests. So in Foundry, for running test, we need to run a command forge test. So let's just go and run that command. Yeah, so as you can see that we have our test failing. So the reason for that as is like we are not compiling our contract straightforward. Like we are using something called Vyper deploy a script, and we are using the address returned from there, and we are then defining our interface and using that. So for that we are using something called FFI of which is native from Foundry. So what FFI enables us to do basically is it allows us to run arbitrary commands. Let's say Vyper and then the name of the contract, which basically compiles our contract. Vyper contract is not natively supported. So we will be using something called FFI, which allows us to run arbitrary command, and in that way we'll run this Vyper and contract name. So it will compile our smart contract and return the address. So for that we have to enable FFI in our Foundry. So for enabling that we need to pass this dash dash FFI flag. to our test script. So what it will gonna do, that it will go ahead and tell Foundry that we have FFI enabled, so we should run all the arbitrary commands specified in the test script. So now let me just hit the enter. Okay, what expected 0 set count. It has something to do in our contract. Let me check. Mm,
Well, maybe check the interface. There's a comment saying that it might be in the interface.
I don't think so. It is in the interface. It is here only in set count. Let me just cross check my test.
Yep.
Mm, get count. Why it is saying that? Okay, yeah. Okay, yeah. So we have to accept one argument over here. I forgot that. uh, which is of the variable u into 56. Yeah, so we have to accept one argument in set count, and I forgot to add that. So maybe it should be fixed now. Oops, what I did. Yeah, perfect. So let me just clear the screen and run that again. So as we are now FFI enabled, we are passing all the tests. And yeah, so up till now, what we have done, we have written Vyper contract, written deployer script, which deploys our Vyper contract and returns address. And after that, we have defined interface, which basically gives which helps us to interact with our smart contract while testing. And we have our test written in Solidity, which helps us to assert some of the values and test our smart contract. So the next step would be to deploy our smart contract to a network of our choice. But before that, let me know if you have any questions up to this. I'll be happy to answer that.
Just to jump in, really amazing explanation so far. I think for a bit I forgot I was like a host and I was just looking at it from like a learner's perspective, because you like have literally explained every bit of information, every small like nuance that's there inside this. So good stuff so far.
Cool. So let's just go ahead and deploy our smart contract. So for deploying Vyper contract, there are multiple methods. Like we can just use Gist or Math, which are some of the CLI tools for our deployment. And apart from that, there is also my Ether wallets, which allows us to paste the ABI code and that bytecode into a browser, and it will allow us to connect MetaMask, and then we can just deploy it from the browser. But here, what I'm gonna do, I'm gonna head to the Remix and deploy our Vyper contract from there only, because this is the most preferred way, because you don't have to install any of the command line tools or any of that in your local setup. So that's a preferred method, and I'm going to do that. I'm going to go with that only. So let's just go with remix and copy this whole contract, and let me paste over here. Just delete this
Can you zoom
and
into your
create a new
remix?
file. Sure.
Yeah.
Is it perfect?
Yeah, that looks good.
Okay. Yeah. So again, the name of the file would be contract dot vy, and I'm going to paste this over here. So in Remix, we have to add a plugin to compile our Vyper contract. So what I'm gonna do, I'm going to here with swap this socket button and search for Vyper. So as you can see, I have already activated, but for you it might be deactivated or something like that. So yeah, after that we just have to go over here and just wait for it to compile. Yeah, perfect. So we have this whole compile button. I'm just gonna click it. So I don't know why it is not scrolling down, but we should see a whole, yeah, this is the whole API for our smart contract. And now we are going to deploy it. So I'm going to go over here, and you can also use your injected provider, which will connect your local MetaMask. I'm going to just this virtual environment, and from here I'm going to select this Vyper and uh, pass any random 21 number, and we'll deploy it. So as you can see, our contract has been deployed, and we can just interact from here. Let's say 11, then count variable is 11, all those stuff. Perfect. So this is the pretty much whole thing about Foundry, Vyper, and starting from writing contracts to deploying, compiling, writing tests, and yeah, that's all from my side.
So like one question, when you just entered like 21 while deploying the contract, that was setting the initial value of count, right?
Yeah, yes.
Okay.
So let me just do that again. So
Yep.
I'm passing here any value, let's say not 21, 55. So let me just deploy it, and we had passed 55. So here we should get 55. Yeah, perfect. So that just sets initial value, and we change it to anything like 22, then it should change to 22. So yeah.
Sweet. So
uh,
any
Happy to have questions
questions?
on this.
I think he disconnected by mistake. Just
Oops, I just left this studio.
yeah, exactly. I thought the same. So Nazi, you have an article that speaks about the same, right?
Yes.
Yes, I'm just going to drop that in the comments as well.
Yeah. So I have a few more resources on Foundry. Like one of them is like pretty good by Neither. Let me ping that as well. And apart from that, there is also my another article where I have explained in depth about Foundry. It doesn't contain Vyper, but you are gonna get the in-depth knowledge about Foundry. So here it is. Yeah. So in these are the two things where you're gonna find some advanced information about Foundry, and also like you can always refer to the docs for both Vyper and Foundry. Am I audible? I think we lost Europats. Or no, Viper don't compile in Solidity. It basically by compiling it returns bytecode, and by we are deploying that bytecode using a command called forge create. So what it does is basically takes a bytecode and deploy it to a address. Viper doesn't compiles to a Solidity. I think there is some issue, network issue with Ropats. We are
Yeah, I'm
gonna
so
have it
sorry,
next.
guys. I had like a network issue. Sorry, extremely sorry for that. Can you all hear me now? Can you hear me, Nazi?
Yeah, we can hear you. Yeah.
Okay, sorry. So I'm also pasting some additional links that Nazi has posted. One is the link from Nader, and the other is his own article about Foundry. And yeah, I guess if anyone has any questions, open to that. But super, super amazing workshop, Nazi. Like I said earlier, you've like explained literally everything pretty well. So it's like really useful for even newcomers to understand what you're doing. And like you said earlier, the syntax of Viper and Foundry is simple enough to understand. So yeah, like Solidity still has a bit of a learning curve, but this was amazing.
Yeah.
So
Yeah.
thank you so much.
Thanks, Ropats.
It was my pleasure once again, guys. Follow Nazi on Twitter at Nazi21. A really amazing dude. You should just get in touch with him. He's always ready to help and is always working on cool projects. So definitely check out his profile. Get connected. Yeah, and thank you so much for attending the workshops. I'll see you all soon, guys.
Yeah, and also a huge shout out to Ropats. His username is Ropats16. He's also an amazing guy.
Thank you so much. Bye, guys.
Bye, guys.